Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Acid Bases and Salts. In the previous video, we discussed the physical properties of acids and the chemical properties of acids. We learned acids are sour in taste, they turn blue litmus to red color, and they conduct electricity. Today we will discuss a few more characteristics of acids. We know acids are a group of compounds having these physical properties and certain chemical properties that we already discussed. So what do all these compounds have in common so that they all behave the same way, or we consider them as a group called acids? Basically speaking, all acids have hydrogen in them. You know, hydrogen is an element. Every acid, if you see, they have hydrogen present in them. We know there are different types of acids, strong acids or mineral acids which we obtain from the earth crust, hydrochloric acid, HCl, sulfuric acid, H2SO4 or nitric acid, HNO3. Here all what is common? Hydrogen is common. Apart from this, there are certain weak acids also. They are organic acids. Organic acids means they are part of living things or substances which occur naturally. Like in some fruits, we have oxalic acid in tomatoes or a citric acid in lemon, or in the curd we have lactic acid. These are organic acids. They also possess hydrogen. So all acids have hydrogen. But simply if they possess hydrogen, can we call them acids? Obviously no. Think about water. Water has hydrogen in it. But is water acidic? Absolutely not. What is making the difference? An acidic substance, when it is dissolved in water, it will dissociate to form hydrogen ions or H plus cations. We call it as H plus aqueous ions because it is produced only when it is dissolved in water. Aqueous means what? Dissolved in water. So whenever you write, simply if you write H plus ions, it's wrong. You have to mention H plus aqueous ions. One more way you can write it, that is H3O plus ions, means hydronium ions. Hydronium ion is nothing but H plus ions plus water. Okay, so either you have to write H plus aqueous or H3O plus ions. Please don't simply write H plus, it is wrong. Look at this equation given here, hydrochloric acid. Within bracket is written aqueous because only in water they dissociate. What do we get? H plus ions cations and a chloride anions. So they dissociate completely. And because of this H plus aqueous ions, this hydrochloric acid is showing the property of acid. Let us see a few more examples. Sulfuric acid, H2SO4. It will dissociate to form hydrogen ions and sulfate ions, 2H plus and SO4, 2 minus. It's not 42. The font is written like SO4, you know, sulfate, and 2 minus is its charge. Then nitric acid, aqueous, H plus aqueous and NO3 minus aqueous. The same way CH3COOH will become CH3COO minus and H plus aqueous. What is CH3COOH? It is acetic acid. We will learn in the 4th chapter about it. Now, if we discuss other compounds having hydrogen, like I told you about water, the same way glucose. Glucose formula is C6H12O6, and alcohol. Alcohols have got a functional group OH which gives them alcohol properties. So, whether you consider glucose or any of the alcohol, they also contain hydrogen. But do they show acidic character? No. As we discussed, if they want to show acidic character, they have to dissociate in water to form H plus aqueous or hydronium ions. But when these substances are dissolved in water, they don't dissociate to form hydronium ions. So they are not acidic in nature. From this, what can we conclude? All acids contain hydrogen, but all the hydrogen containing compounds are not acids. Hope you are clear with this concept, what we learned. I will just summarize. That is, acids have hydrogen present in them. And this hydrogen, on dissolving in water, will become H plus aqueous, or the acids, they dissociate to form H plus aqueous ions, or otherwise we call it as hydronium ions. Because of the presence of H plus aqueous or hydronium ions, they show acidic properties. But other hydrogen containing compounds like glucose, alcohol, etc., they do not dissociate in water to form H plus aqueous ions, so they don't show acidic property. There is an activity in your textbook to show that all the compounds containing hydrogen are not acids. Here you can see two pictures. One is hydrochloric acid, the other one is glucose. In both this, in the beaker, there is a cork. To that cork, two nails are fixed. The nails are connected to a 6-volt battery, and which in turn is connected to a bulb. There is a circuit, and there is a solution which is immersing part of that nail also. That solution in the first beaker is dilute hydrochloric acid. Second is a glucose solution. Both are substances containing hydrogen. Now once we switch on the switch, electricity starts passing, and you can see that only in hydrochloric acid the bulb glows, whereas the glucose solution bulb does not glow. Is there any reason for that? Here, aqueous solution of an acid conducts electricity. That is in the case of hydrochloric acid due to the presence of charged particles called ions in it. We saw hydrochloric acid dissociates to form H plus ions and Cl minus ions. They are ions which can conduct electricity. Only because of that the circuit is complete and the bulb is glowing. Whereas in glucose or alcohol, if you take any acid, we get the same result. The same way, glucose and alcohol do not produce hydrogen ions or some other ions in solution. So due to the absence of ions, glucose solution and alcohol solution do not conduct electricity. So hydrogen containing compounds like glucose and alcohol don't show acidic properties as they don't dissociate in water to form H plus ions. So we just saw an activity to prove what we learned in the previous part of this lesson. There can be one more question about distilled water. Can distilled water conduct electricity? No, distilled water does not conduct electricity. But what about rainwater? Rainwater can conduct electricity. Why this difference? Distilled water does not contain any ionic compound dissolved in it, whereas rainwater has slight carbon dioxide dissolved in it while it is falling through the atmospheric layer onto the surface of earth. Acidic gas carbon dioxide dissolve in water to form a weak acid called a carbonic acid H2CO3. Due to the presence of this carbonic acid, it provides ions to the rainwater and can conduct electricity. So the basic requirement for conducting electricity is the formation of ions. Can acids show acidic behavior in the absence of water? No. This is another important concept that we have to understand. When dissolved in water, will dissociate, right? But if water is not there, can they produce ions? Absolutely not. Acids in the absence of water cannot dissociate into ions, so they cannot conduct electricity or they will not show acidic behavior. So, in the absence of water, acids cannot form H plus aqueous ions and hence will not show its acidic behavior. We have an activity to prove this. This activity, we have to take about 1 gram of solid sodium chloride, that is NaCl, in a clean and dry boiling tube. And we have to add some sulfuric acid to it very carefully, because you have to be very careful when you are handling strong acids, because acids are corrosive in nature, they can harm you, right? So you have to be very careful in adding sulfuric acid. Then after that you have to fit a rubber cork with a small glass delivery tube in the mouth of the boiling tube, and concentrated sulfuric acid in the boiling tube by the time reacts with sodium chloride to form hydrogen chloride gas. The hydrogen chloride gas starts coming out of the open end of the glass tube. At this time, we have to hold a dry blue litmus paper in hydrogen chloride gas. We know acids change blue litmus paper into red. But in this case, we don't see any change in the color of dry blue litmus paper. This shows that hydrogen chloride gas does not have an acid behavior in the absence of water. That's why it's not turning dry litmus to red. Now what we can do? We have to hold a moist or a wet blue litmus paper in the same position. That is where the hydrogen chloride gas is coming out. At this time, we can see the moist blue litmus paper is turning into red color. What does this indicate? This shows that hydrogen chloride gas shows acidic behavior in the presence of water. From this activity, we can conclude that hydrogen chloride gas does not show acidic behavior in the absence of water, but it shows acidic behavior when water is present. Dry HCl gas does not contain any hydrogen ions in it, so it does not show acidic behavior. In fact, dry HCl gas does not change color of dry blue litmus paper because it has not uh, no because it has no H plus aqueous ions. Whereas when it comes in contact with the water, it will dissociate to form H plus aqueous and Cl minus aqueous. As a result, it starts showing the acidic property and change the blue litmus color into red. So I will just summarize all the points that we learned. First, we learned that all acids have hydrogen in common, and acids on dissolving in water will dissociate to form H plus aqueous ions or hydronium ions, which are responsible for the acidic behavior. And all hydrogen containing compounds need not be acidic because they do not form ions in the presence of water. Then the next point we studied is acidic property can be shown by an acid only in the presence of water, because only in water it can form H plus aqueous or hydronium ions. And we learned two activities also. Hope this is clear. Now we are moving on to another important concept that we have to study. This is the explanation of that experiment that I discussed. You can read through it. Now we are coming to a concept of strong acid and a weak acid. But here one thing you have to be very clearly understand, that is there is no correlation between strong acid and a concentrated acid, weak acid and a dilute acids, because children always confuse with it. So please identify these two separately. First we will learn strong acids and weak acids. Then we will understand concentrated acids and dilute acids. Okay. So what are strong acid? Strong acid means acid which is completely ionized in water. As a result, it produces large amount of hydrogen ions. Okay. So HCl, H2SO4, that is sulfuric acid, HNO3, nitric acid, these all completely dissociate or ionize in water to form H plus aqueous maximum. So they are strong acids. So strong acid indicates, or strength of an acid indicates the degree of ionization, how much it can ionize. That shows the strength of that acid. Strong acids react rapidly with the other compounds, and also they are good electrolytes because they produce large number of ions. When it comes to weak acids, acids which partially ionizes in water and that thus produces a small amount of hydrogen ion is called a weak acid, because these acids don't produce large number of hydrogen ions, and completely it is not ionizing, partially only it is getting ionized. For example, acetic acid CH3COOH, it is partially ionized in water to produce only a small amount of hydrogen ions, so it's a weak acid. And another weak acid is carbonic acid H2CO3. And what about the properties? They are having slow reactivity, they slowly react with other substances, and also their conductivity is also less because they produce less ions. So hope you understood what are strong and weak acids. Strong acids have completely ionizes in water to produce large number of H plus aqueous ions. If they partially ionize in water and produce small amount of hydrogen ions, then it is called a weak acid. Now we will discuss a few uses of mineral acids. Sulfuric acid is used in the manufacture of fertilizers, paints, dyes, chemicals, plastics, synthetic fibers, detergents, explosives and car batteries. Nitric acid is used for making fertilizers and explosives, dyes and plastics. Whereas hydrochloric acid is used for removing oxide film from steel objects and for removing scale deposit from inside the boilers, dye, textiles, food and leather industries. Just now we saw the concept of strong acid and weak acid, and we learned that strong and weak acids are based on their ability to dissociate into ions. Whereas now we are coming to another concept of dilute and concentrated acids. So anything when we are talking about dilution, that means we are adding more solvent to it. So before we start, I will just give you an idea about solvent and solute. You know, if you take some water in a beaker, that is called that's a solvent, right? To that we are adding either sugar or salt. Both are solutes. So first, if you are adding 10 grams or 200 ml of water, so some solute is there. Now it is called a solution. Solvent and solute together we call it a solution. Then you add 20 grams, then you add 50 grams, then you add 100 grams. That there will come a stage where you will not be able to add or dissolve more solute in that solution under that particular temperature. but by increasing the temperature you may be able to dissolve little more, but after that again there will come a stage where you will not be able to add more solute to it. Such solutions are called as saturated solutions. All those concepts you learned in class 9. So now you remembered what is solute, what is solution, right? When a solute is dissolved in a solvent, this is called a solution. So when we add more water, that means more solvent is there, that is called a dilute condition. When less, or in terms of solute, if you say less solute means dilute, more solute means concentrated. So here also concentrated acid means what? It is the one which contains very large amount of acid than water in the solution. So water is less, acid is more, then it is concentrated. So they have more number of available ions, and whereas a dilute acid is the acid which contains greater concentration of water in it. That is, acid is less, water is more, then it is called a dilute. Concentrated acid can be diluted by adding it to water, because we know most of the time in the labs we have to use dilute acids or acids of different concentration. So we will have to dilute the acids, and once we dilute, they will have low number of available ions in solution. Now this is another important question for you, process of dilution. So dilution is a process of decreasing the strength of an acid, or we can do dilution for base also. We know that acids are acidic in nature because of H3O plus ions, whereas bases have the property because of OH minus. We will come to that later. So once they are diluted, what happens? That is, more water is added. As a result, concentration of H3O plus or hydronium ions per unit volume will decrease. Such an acid is called a dilute acid. So once you are diluting an acid, you can follow a procedure, that is, acids can be diluted by adding small amount of acid to water drop by drop with constant stirring, because it is a highly exothermic reaction. So if you add water to the acid, it will create a lot of heat and the blasting can occur. It is very dangerous. So dilution of acid is highly exothermic. So diluting acid with water is very specific process, and it is dangerous if it is not done correctly. So keep in mind, acid should be added drop by drop to water with a constant stirring. This is a very important question. So today we learned certain additional properties of acids. That is, acids contain hydrogen. They can dissociate in water to form hydronium ions, which give them acidic properties. All hydrogen containing compounds are not acids. Acids can change or change the color of litmus paper or show acidic properties only in the presence of water. And also we learned the concept of strong acids and weak acids. At the same time we learned dilute acid and concentrated acid as well. Also we learned the process of dilution. Hope these concepts are clear for you. If so, please like, share and subscribe to my channel, Biology My Passion.